I'm Matt Slauson. I'm a technology teacher at Skaneateles High School. I'm going to take you through these instrument projects we've been doing for the last half dozen years or so. The past 2 years we've been making acoustic mandolins, and here's an example of one we made last year. This instrument was made in a combination of CNC and laser engraving and a great deal of handwork as well. The necks were cut on the CNC machine. The bracing inside the mandolin was cut on CNC. The peg head was cut on the CNC machine. The veneers were cut with a laser engraver. The tops and backs of the mandolin were cut on the laser, rough cut on the laser, and markings for the bracing were laid out with the laser as well. And then it was glued together. The sides were hand formed on a bending jig. And so in addition to a lot of CNC and laser work, there was a lot of handwork the students needed to do. So this is a project I do in a class called Computer Integrated Manufacturing. And what I wanted to show you was the project we're going to do this year. This year I decided to do a solid body electric mandolin, and this is the body and the headstock that's roughed in. So it will end up being like this. It's a semi-hollow body. There's 2 cavities here. We're not quite done with the bodies. There'll be a single coil pickup, 2 F-holes, and then we'll of course finish it with some veneer and some inserts for the back of the body. My goal this year is to introduce the students to electronics by also teaching them how to wire the electronics for the electric mandolin, as well as we're going to make our own electronic pickups. So the way this works is students glued together a slab of wood, and this happens to be 4 pieces because that's what we had in stock. This is maple. So this maple block will get fastened into the CNC machine. The Cnc Router was one of the first projects we did in the sim class. A student, Corey Knighton, who's now at Rochester Institute of Technology, helped me build this when he was a sophomore. Corey cut all the steel up for me and helped me weld it together, and I designed and did the control systems for the router. Corey was indispensable in helping me build this machine. So all these mandolin bodies we've been building and all the CNC stuff wouldn't have been possible without the help of my students. What's Inventor and why are you using it in making the mandolins?
It is a solid modeling program, and we use it to design the body of the mandolin and the neck and the head of the mandolin.
Okay,
yeah.
Thanks, Christine.
You're welcome.
So what's EdgeCam and how are you using it in the mandolin project?
EdgeCam is a computer program where you create what it is that you're trying to machine, and then you can use roughing and profiling procedures to basically machine it out, and then you can, it's kind of like printing it, but you print it out onto the machine out there, and the machine runs the program, and as long as you didn't screw up, nothing explodes. So we've created the mandolin neck in EdgeCam, and that's pretty much how we're using it, is we're using EdgeCam to create the mandolin neck.
What's the CAM stand for?
Computer-aided machining.
Thanks, Colby.
Yep.
Okay, Steph, what are you doing and why are you doing it?
Right now we're using the program from the CAM software that has gone into the computer as G&M codes to create the mandolin body by having the router follow the toolpath from the program.
Okay, thanks, Steph. So what's a post-processor?
What you see, it is a code generator that really edits the code for a specifically made machine, because not all codes are made for one machine. It's made for a generic type, and then the post-processor will then change it for a custom-made machine, because not all machines of the same type of coding is needed.
Okay, thank you. So how do you calculate spindle speed, and what happens when the diameter of the tool increases or decreases?
Spindle speed is calculated by CS times 12 divided by pi d, and as your tool gets larger, your spindle speed will go down.
Thank you. So how do you calculate feed rate in the XY plane?
You take the spindle speed multiplied by the number of teeth multiplied by the number of teeth per inch.
Thanks. What are you guys doing and why are you doing it?
We are going to engrave our names, Computer Integrated Manufacturing, class of 2011-2012, Skaneateles High School, in this little pocket right here to show that we are that we're like makers.
Yeah, we made it. It's kind of like adds some, makes it a little special. Like take pride in your work. And
it's
names on it.
like handcrafted by us.
Yeah.
So.
Okay, thanks guys. So what are you doing and why are you doing it?
I'm engraving my mandolin, and I'm doing it so I can show my products, and it makes it legalizes that I'm producing it.
There you go. So what's a can drilling cycle and how do you use it?
Alright, the can drilling cycle code is a G81, and you use it by putting in the G81 with, you rapid transverse to the first point, X and Y value, then you G81
retract, and where you do Z depth for the drilling depth and R for the retract. And after that, you just put the X and Y coordinates of each code, and then G81 or G80 at the end, which is the cancel can drilling cycle.
Okay, thank you. So how do you create a clockwise arc?
In code, it's a G02. You put the X coordinate, then the Y coordinate, and after that, that's the coordinate you want to go to, and then you put the center point of the arc you're making with I and J.
Okay, thanks. So what are the codes for rapid traverse and linear interpolation, and how are they different?
Rapid traverse is G00, and linear interpolation is G01. They're different in that a rapid traverse is to move quickly to a point, and a linear interpolation is for cutting.
Okay, thank you. What are you doing and why are you doing it?
Use the table saw to cut fret, where the fret pushes it out.
Okay, thank you.